Hello, welcome to the intro to our pre-class video. So I'm just going to show you what you need to know to be prepared for class this week. So here we're going to start on the eCampus lab page, lab week 6. And I just have a brief summation about like what we'll be doing today or this week. And I have some things I want you to do before class, and I'll be going through most of these with you. So you can see right here at the top, hopefully, this video that you're watching here. This is an older version. I will update it with this video that you're watching now. So I want you to download and read sections 1 through 3, at least 1 through 3. For the R freshwater ecology, it's going to be a PDF. So that's this right here. This is the PDF version. It has a table of contents. Inside this folder, I also want you to download the R folder for lab 6. So it's going to be zipped. You'll download that and save it wherever, probably in your class folder. That'll be useful for you, somewhere you know where it is. So in there, you have that PDF that I just referred to. You also have this HTML version. If you double click on that, it'll open it in your browser. And that's what this is right here. And then the next thing we'll talk about is installing R in RStudio and installing the required packages for this week's lab. So I will go through that in depth, but I want to first just show you kind of the brief overview of this document that I made for you. And I'm hoping that this document will be a good tool for you, both for this class and for, sorry about that, for if you want to use R going forward. I hope this will be a good reference for you. So it starts off just kind of like very basic like definition of R. And then like installing R. So it has links. So if you have Windows, which I assume most of you have, you just click this and it will take you to where you need to download R. Just run it with your regular installation wizard like you would. And then once that's installed and working, you need to do RStudio. So RStudio is a graphical interface for R. It will not work without R, so you need to have R already installed. And for Windows, you can just download it here. Mac, Ubuntu, Linux, like whatever version you have, you just download it and follow the regular methods for your operating system. I've not used Mac before, but I know people who work with Mac or are on Mac, and it should work pretty much the same. If you have any questions, let me know, and I'll do my best to help you if you have any issues getting this running on Mac or Linux. I've done it on Linux before, mostly like Ubuntu and Debian, but I should be able to help you out no matter what Linux operating system you have. Although I imagine not many of you, if any, have Linux. So it's just a little blurb about updating. You should be good since you're just installing it now. But we can go through that. And then I need you to install several packages. So we're going to use the Tidier, the Dipler, the FSA, and the vegan package. So we'll go through that. So here's just a brief section about like why R is good to learn. Read through that. There's a lot of advantages to it. It's helped me a lot in my career. If you're going to do anything in the sciences, or even if you're going into like a financial field, whatever it might be, R is a very useful tool to you. It's helped me get a lot of jobs. It helps me stand out a lot from my peers, and it really does streamline if you're going to do any sort of data analysis. It'll help streamline that workflow for you, especially if you're going to be working with large data sets. It's a lot more manageable, and it gives you a lot more power than, say, Excel would. That is to say, or not to say there's not other great statistical programs out there. One of the advantages to R is it's like wide acceptance and use, but also the fact that it's free and open source and people add to it. So there's a lot of user-made functions that are for very niche things that you wouldn't get in a different operating system where people aren't allowed to add to it because it's proprietary. So that's one of the advantages. Section 4, we're going to kind of go through in class and partially in this video, but if you want to read it, it'll help you get ahead and maybe understand a little bit more, kind of like what is piping is good. It explains some of these packages. So I guess that's section 5. It's way more than you need to know, but if you're really interested in R, piping is a way that will really streamline your coding and make it a lot easier to read. But there is an extra package in this function. So this is something I wrote for another class that I taught. Well, I didn't teach. I did like a lecture, a portion of the lecture on piping. And then down here on 6, I made this sort of quick reference guide, which I hope is useful to you. So these are a lot of the commands we will use in this class and other commands that I thought were just useful in general that I wanted you to be able to know. So install packages, you can click it, and it'll take you to this little documentation page here. Oops, I should have hit the back button. So that's just kind of like some functions I thought were useful. You can read through it. I wrote kind of like a little blurb about what it is and what it does, and then the links should all work. So there's also this getting help section within R. You can use these question marks. So you can do question mark mean, and it'll kind of bring up that page, which if you also click this, it'll bring up that page. That's basically what I'm doing there for you. But this is if there's a function that's not included in my list, you can do this within R. You can do it within RStudio also by just going to help and typing in the function. So there's also packages and vignettes. You can browse those. You can also just Google it. Yeah, you can find other functions. This is a little blurb on dealing with errors. Might be useful to read through. So there's several places to get help. One of the most useful things is just go to Google or whatever search engine and say, how to plot whatever, just whatever your question is, just put R in front of it. And you can get a lot of good answers, not always completely reliable. If you want more reliable or answers that you might have to wait a little bit for, Stack Overflow, you'll create an account so you can post, and it's pretty useful. A lot of times if you just Google things, it will come up with a Stack Overflow question. So here if you're looking for R stuff, you're just on Stack Overflow, you do brackets R, and it'll take you to this R section. So you can see here's just like the most recent questions people are asking. This is the little tag. And people like give answers and you upvote and choose it. So this is like how to make a great reproducible R question. So in this is also this how to ask a good question. It brings you to this link. This might also be useful to read. They want you to make a reproducible question. There's certain syntax for how to write your code. So let's look at a random question here. So you can see they wrote the code and gave the output, then asked their question. Then people give answers and they selected the one that worked. So that's useful generally. And most questions you're going to have are already going to have answers in here. So if you just do the Google search, maybe R, whatever your question is, you'll probably find it. So that's a useful resource if you need help. Yeah, so that's basically the overview of this document. Definitely read sections 1 through 3. We're going to kind of go through 3 a little bit today in this at the end of this video. 4, we're going to go over a little bit in this video, a little bit in class, but there's a little more in there. And 5 is just definitely extra if you want, but it might be useful if you're really interested in R to read through these things. So you should just follow these instructions, have R installed. So R in RStudio, so you'll click on your little RStudio icon. And you should have unzipped this folder here. So you can see this folder has your R scripts. Everything with .r is an R script. Has those 2 versions of that guide I created for you. Has a data folder, which I like to have raw data and clean data, and I've provided everything for you. So if you mess up, you can just re-download it and get the right stuff. I'll be showing you how to create those and navigate these directories. And then you'll have your figures output into this folder. Doesn't matter if you don't. I just like to organize it. I'm just showing you how I organize things. So you have this folder. I'm going to show you, if you go up to, first, let me show you this. So you go to my RStudio, might look different than yours. I have a different theme and my layout might be different. So if you go to tools, global options, you can change the appearance. You can change kind of the theme. I like modern. You can change the font. You can change the font size and you can change the theme. I'm using Cobalt. And then the panel layout, I like to have console top left, source top right, and have environment, histories, connections, build, VCS here. Honestly, the only one I ever look at is environment. And then I have files, plots, packages, help, and viewer here on the right. So you can just check these boxes if you want to make it the way I have it. However you want it is fine, but this is the layout I have. I'm not sure what the default is. I don't really want to reset mine. So if you want to just copy this, feel free to pause the video and do this now. And really the main ones we're going to use are files, plots, packages, and help. And then just hit apply and you're done. And feel free to go through and play with whatever themes you like. I like to change it up every now and then. None of that matters. And you should be good. So the next thing we're going to do, so when you open this, this is your R console. This is the version of R I have. Yours might be slightly different. I probably need to update mine, which maybe I'll do at the end of this video. Go to File. So let me show you right now. If I were to type in get WD, get working directory, you can see this is the path. So this is where I am right now, where R is, and it's in my documents folder. And I want to be in this folder, right? The Lab 6 Intro to R. There's other ways to do this. I could go to session, set working directory. I could do it with code. I could do set working directory and then type in the path within quotations as this is. But the way I like to do it is to go File, New Project. And then since you downloaded that folder I gave you, go to Existing Directory, and then Browse, and then just find that folder. So mine's on my desktop, Lab 6 Intro to R, open. You can click Open in a new session if you wish. So I'm going to create the project. It's going to load. And now I can see here everything that's in that folder, right? So I have my R scripts.r.r.r, my data folder, my figures folder. This is a new link. So this is my R project link. My first script, and then these two, which is those guides I created. So the fun thing about creating that is if I just exit out of this, you can see here I have this new little square with an R icon in there. It says .rproj. If I double click on that, it opens RStudio straight to that working directory. And that's really handy. So we'll kind of look at this at the end of lab today, or at the end of this video rather. Sorry, I showed you the get working directory command, which is here. Now you can see my working directory is correct. If I wanted to do that via code, I could come up here. Let's see, copy address. And then I would type in set wd quotations, and then just copy and paste that path. Oops. You know what? So you notice these slashes are the other way. So I think I need to do that. I haven't done this in so long. Yeah, see, you can see that. Oops. So you might have to fix that. I don't know if that's a little different on our Mac as well. Obviously, I never do it that way generally. I just wanted to show you it because it's so much easier to do it within RStudio. So the next thing we're going to do, we'll go back here and we'll scroll down. So install required packages. So there's multiple ways to do this. We need the tidyr, the Dipler, the FSA, and the vegan package. So if you want to do this in the console, you can use this command or function called install packages. And then within parentheses and quotations, just the package name. And you got to make sure you get that spelled correctly. So if I start typing install, it just kind of pops up here with RStudio, which is nice. Then make sure you have your quotations, TIDYR, I think is right. And then just hit enter. And it's running that. And you see this little caret, which means it's done, it's run. So the other easier way to do that is you just go over here to this packages tab and hit install. And then we need Dipler, DPLYR. It pops up. Don't really need to mess with repository or library. I generally keep install dependencies checked. And when you hit install, it may pop up and ask you what CRAN mirror you want. This doesn't matter which one you choose. They're all the same, more or less, or they should be. Basically, you just want to choose the one that's closest to you. But it, again, doesn't matter. It'll just be a little slower if you choose one that's farther away. These packages aren't huge, so it really shouldn't matter at all. So just hit install, and it'll run that for you. And it's done. Now I'm going to do FSA, all capitals. And that's done. And now I need vegan, VEGAN, all lowercase, install. So I'm going to go back to files. I have all my packages now. And I'm just going to show you, this is where your scripts will be. So this is that source, sorry. This is that source section I showed you in the panels layout. I'm just going to load that and this first one. So these are what we'll be going through is load and clean data, visualize data, and data analysis in class. And I labeled them 1, 2, and 3 in the order we'll be going through them. But I just want to show you, even though we've installed those packages, before you can use them, you have to use this library command. So library tidyr. And every time you open R, you'll have to reload the packages that you want. So you can see here, I have a few warnings. It was built under R version 4.303 rather. And I'm using 02. Shouldn't be a huge issue. Probably won't be an issue for you. But I would need to update R if I wanted to get rid of that. It also says objects are masked from these packages. Don't worry about that. You're fine. Yeah, so this should all work. So that's how you load your packages. And you'll have to do that every time you restart R if you want to use those packages. So that's basically what you need to know for a class. I'm just going to show you some things just to kind of help familiarize you with R. So again, I showed you this get working directory command. This is how you would set the working directory. This dir command is useful. It shows you what's in your directory. You can also do this folder thing, these files down here, and you can put a path inside there. So say I want to see what's within the data. I can see it's clean data, my data log, and raw data. And then if I want to see what's in raw data, I can just see it's this CV. So I like to do that sometimes if I'm like not entirely sure how to spell or how I spelled something, I'll just copy and paste this and then put it in. So MT cars, R is an object-oriented programming language. So MT cars in this case is our object. It's really handy because it's already loaded into R for us. So I'll just show you what that looks like here. Fun little thing, you can click this big box here. If you click this, it makes it small, big. If you double click when it has the 2, it makes it back to normal. So we'll make it big. You can see here is a data frame. So each column is labeled. The rows in this case are labeled in their individual cars. So this is what our MT cars data frame looks like. This is an object. This is what it's named. So it's just preloaded into R, used for examples. We'll have to load our data into R, and I'll show you how to do that in class. Generally, the row names are just like 1, 2, 3. You can name them. They named them because they're each an individual car in this case. So as head function, so you're going to do head, and then in parentheses, you put the object. This works well if you have a larger data frame. It shows you the first 6 rows of data. And it just is a neat and easy way to see what your data looks like. And then this structure command works good. It tells you what it is. So in this case, we have a data frame. It might be a vector. It might be a list. We're going to be working with data frames in here. We'll also be working with a few vectors, but mostly data frames. Excuse me. So you can see you have 32 observations. That corresponds to 32, rows of data. And you have 11 variables, and variables refers to our columns. So we have 11 columns. And then it says miles per gallon, cylinder. These are all numeric variables. That's what this refers to. And it shows you like kind of the first few. So for each variable, you can have factors, you can have logical variables, character variables, different things. You can have date format. We'll go through that in class as well. But you can see there's a little $ in a space, ignore the space, and then the column name. So if I'm interested, if I'm doing MT cars, oops. And this is a data frame. This only works with data frames. It works, I think, maybe with lists too. And I put the $ after the object. It'll tell me, it'll give me this list of all the columns. So if I click on that, so $ and then the variable I'm interested in this case, miles per gallon, and hit enter, it'll show me just this column in the form of a vector. So just this miles per gallon column. And you can see that here. So that's a way to pull out your variables and just look at them. So say I want to know the mean, what's the average miles per gallon for all cars? I would use this function mean, parentheses, MT cars, $MPG. Within the function, you separate commands with a comma. And then this na.rm equal t means remove na. So na remove equals true. So basically, there are no NAs in here. If there were, this function would not work without this little command here. So I'm just showing you that. If I hit enter, you can see this is the mean of that column. So this is an average miles per gallon. Again, the same syntax, but SD for standard deviation. That's the standard deviation for miles per gallon for that column. The average for each cylinder. So this aggregate command is useful for that. You can do MPG tilde cylinder. So this is sort of like Y, if you think of it as a figure. Our Y-axis would be, our response would be miles per gallon by cylinder. So we want to know what is the average, so the mean of miles per gallon by cylinder. So if I type in this command, unique MT cars, $, CYL. You can see we have 4, 6, and 8 cylinders. So we have 3 unique values for cylinders. So this should give us 3 unique values for mean. So we're going to do the command aggregate parentheses MPG tilde cylinder, comma, data equal MT cars, comma, FUN capital for function equals mean. No parentheses, you got to end your parentheses, but no parentheses for mean, just the function mean. And then this little caret and dash, it looks like an arrow, is your assignment operator. So it's going to say, take this function, perform this function, and assign it to this object. So whatever name we choose, I chose miles per gallon cylinder average. So if I run that, you notice I don't get an output like I did before down here in my console. And that's because I have to run this object. So I'm up here, and I run that object, and I get this output, which is the average for 4, for 6, and for 8 cylinders. I guess I should mention what I'm doing here. You can copy and paste if you want into the console, and it'll work. For RStudio, it's really easy. You just put the cursor on the line you want to run and hit Control Enter, and it will run. I think for Mac, it's Command Enter. I'm not entirely sure. So this is the same. The only thing I changed here is this name, the SD, and the function SD. So I want to know what is the standard deviation for miles per gallon by cylinder. So everything's the same, and I run that, and this is the standard deviation for each of those. If I want to see this visualized, the box plot command is useful. That's going to pop up here in my plots. So again, same syntax. So Y on X, so miles per gallon on cylinder, comma, data equal MT cars. And it's just box plot is the function. So if I run that, you can see this is what I've been talking about. Response miles per gallon on cylinder. And it shows you the distribution of your data. So that's a very basic introduction to R. That's all you really need to know. I will show you really quick how to create your own function. So again, we're going to name a function and you're going to assign it. You'll use this function command. So it's just function, parentheses, and then what you're going to have to put in there. In this case, it's our X variable and our Y variable. So we used this syntax here. So this is our Y variable, our X variable, and it's pulling these out. So this would be the same as if I did this, and this is the format we're going to use here. If I did MT cars, $ miles per gallon, MT cars, cats, $ cylinder, then you don't need this data. This would be the same because again, I'm just indexing out these two. So this is kind of the syntax we're going to be using there. Notice I don't have the data in here, but I'm just doing the standard deviation. I made this wrong. So you're going to have to probably fix this if you want to run this. I just did it backwards. So X bar, Y bar, and whatever you put in there, it's going to rename to X bar and Y bar. And that's what you need to put into these functions. I labeled them X and Y variable just to keep it clear in my mind, so it's easy. You probably should use carets instead of, or arrows instead of equals. Either works in this context, but it is good practice to use these instead of equals. I don't know why I did that. So this is our function that we're creating. You'll notice that there's this little curly Q, right? And I ended this curly Q here, so it's kind of handy. If I delete that and just do this, R completes it for me. I like to do 3 spaces and go up and leave the tab. Now you can see there's nothing in here, and R popped up unexpected closing bracket. That's because I created a new one, right? And it's ending, and it's blank, and then it has this code with this, and there's no opening. So R is telling me, hey, you made a mistake in your syntax. So if I go up here and delete all that, this goes away. See, it works now. So this is saying, get the standard deviation of my Y by my X variable, get the average of my Y by my X variable. Then CV is coefficient of variation. I'm creating a data frame where I am dividing the standard deviation by the average that I created below or above. And if I look at this, so this is my average, you can see it's a data frame. So what I'm doing here is just some basic indexing. So use the brackets. If I hit 1, it shows me that first column. If I hit 2, it shows me that second column. So I'm using that second column, which is my standard deviation, and the second column, which is my average. This works for data frames. If I were to do 1, 2, so that'd be the first row, second column. So it's going to show me just this 26 here. And let's see if that's right. Yes. So it's just going to pull that out. If I were to do this with a vector, so say I wanted to know, remember miles per gallon, if I pull that out, this is a vector now. If I do 1, it's going to pull out that first one. If I do 3, it's going to pull out 22.8, which is the third one. If I do 1, 3, it isn't going to work because there's no columns or rows. It's just a vector. It's just a string of numbers, characters, factors, logical values, whatever it might be. In this case, it's a numeric variable. So you only use 1. And that is explained in the document I showed you before. So that's what's going on here. I'm making a data frame with just 1 column, CV, which is calculated here just by dividing. So this is the way you divide these 2 columns together. Here I'm creating a new data frame, which is out. I'm assigning it, and I'm using cbind, which is column bind. So I'm using average, the first column. So again, if I do this, you can see the first column is my cylinders, so 4, 6, and 8. It's just labeling, the cylinders, so it's clear. And then I'm taking the second column, which is my CV, which I calculated here. So it's going to give me this same basic output that I had from my aggregate command, like this, but it's going to give it with the CV instead of the average or standard deviation in the second column. So here I'm naming it. So this names function, you put the object and then the assignment operator. This is how you make vectors. You do C parentheses. In this case, my vector is a string of characters, which are going to correspond to the column names. So I have to put those in quotations. That tells R that it's a character string. So I want cylinder and then CV miles per gallon. Make sure they're separated with a comma rather. and then return out. So I want to return this out, which is output, like my output data frame. So that's the function I created. And if I just run that, there's no errors that has run. Now I can use that function in just parentheses, mtcars $cylinder. So that's my X variable. If we go back to plots, cylinders is on the X, miles per gallon is on the Y. And then comma, mtcar $miles per gallon. So I run that. Again, nothing pops out because I assigned it to CV, miles per gallon or cylinder. So if I run that, I can see this is the CV coefficient variation for 4, 6, and 8. Generally, I wouldn't need to know CV for this. I would use CV for something like precision of age estimates. That's what I've used it for in the past. But this is just like an easy way to demonstrate how to make a function in R. So you should be set for class. Let me know if you have any questions or problems with any of the steps we covered today. And I don't want you to worry about I tried to make everything we're going to go over in class as simple as possible, while still demonstrating as much as possible to you. The documents and things I provided are meant to be a useful resource for you going forward, as well as within this class. I'm not looking to fail anyone, so don't worry too much. I really just want you guys to get an introduction to R, excuse me. And to be able to go forward and do more with it. If you can, it's very useful to me, and I hope it will be to you as well. Let me know if you need any help with this or the assignment, and I will go through it and do my best to help you. Yeah, I think everything that will be due for this week's lab, I've provided you part of, and you just need to kind of modify code, and I'll show you how to do that in class. So again, don't worry about it. But if you do have any trouble getting R to work, please get this done early, so you can ask me for help and come prepared to start class, because we do have a lot to get through. All right, thanks.